Hey class! Today we're going to start one of the last sections and we're going to cover solution stoichiometry and do a chemical analysis. And this is going to lead into what we're doing today and tomorrow. So as a little introduction, in the last chapter we learned that given a chemical equation for a reaction, and if I know the amount of one of the reactants consumed in the reaction, I can actually calculate any other reactant or product within that chemical equation. In this section, we're going to apply that same concept, but to the idea of solutions. Now that we have molarity as a conversion factor, we're going to be using it in this section. So this is a big slide, and this talks about how are we going to use it as a conversion factor. Well, here are the following steps. First, we want to get everything into moles, or our middleman of our compound, our first compound. And the way we can find moles of our first compound is actually by using our molarity conversion factor if we need it. So that means that all of my milliliters has to be in liters first in order for me to use molarity, because remember, molarity is moles over liters, so it has to be in liters. And if you are given any grams, we need to switch that to moles as well because I have molarity here. Now, once I get it into moles of my first compound, to go from one compound to another, we can use our mole ratio. Remember, this comes from our balanced chemical equation in order to get to moles of our second. And then from there, we need to decide what are we trying to get to. If we're trying to get to grams of that second compound, we need to use molar mass. If we're trying to get to liters of that second compound, we need to use molarity. And then if we're trying to get to molarity, we're going to use that second compound's liter or milliliter volume that's given. And this part right here is actually going to be talked about tomorrow because it's a little bit more in depth. So we'll focus on the first two today. So I have 4 examples that we're going to walk through. The first one, it says, how many grams of calcium hydroxide are needed to neutralize 25 milliliters of a 0.1 molar solution of nitric acid? It gives us the balanced chemical equation down below already. So one thing to know, and I'm going to write this, always start with anything other than molarity. So here, the only other thing that we're given is 25 milliliters. And then now that we're working with 2 different compounds here, we need to make sure we keep track of what compound we're working with. So this is 25 milliliters of HNO3. Well, I can't do anything in milliliters, so I have to get it out and I have to get it into liters. So here, to cancel milliliters, we can put it on bottom. And milliliters, we can get to liters. We should know this conversion by now. There's 1 liter. There are 1,000 milliliters. And remember, this is still HNO3. So this is still HNO3. Then we need to convert. So I've gotten in milliliters and milliliters. And our first step is to always try to get to moles. So we have to figure out what allows me to go from liters to moles. Well, the only thing that allows me to go from liters to moles is my molarity. That's why we're using it as a conversion. Because remember, this can actually be written as 0.1 moles over 1 liter. See my 0.1? So if I'm going to cancel out liters, it needs to go on the bottom, and my moles needs to go on top. And remember, 0.1 moles for 1 liter. And still, this is HNO3. So I've canceled milliliters, I've canceled liters, now I'm in moles of my first compound. But I want to get to calcium hydroxide. So once you get to your middleman, you are then allowed to use your mole ratio. So remember, your mole ratio comes from the coefficients of your balanced chemical equation. Here, to cancel out moles of HNO3, it needs to go on the bottom. And I'm trying to find moles of calcium hydroxide. So I'm going to put that on top. Let's look up here. Notice that we have 2 moles of HNO3 for 1 mole of calcium hydroxide. And then now we have it in the compound we want, but it's asking for grams. So remember, we did this last chapter. To go from moles to grams, we're going to use molar mass. So 1 mole of calcium hydroxide, there are 74.0918 grams. And that allows us to cancel out moles of nitric acid and moles of calcium hydroxide and leaves us with grams of calcium hydroxide. When you solve that, we need to make sure we're rounding to the correct number of sig figs. So here we should have 3 sig figs, so 0.0926 grams. And then now that we're working with multiple compounds, it's very important that we make sure that we're labeling calcium hydroxide. Okay. This is 3 sig figs. Remember, the 0 does not count because it's a leading 0. So let's try for example number 2. If you'd like, you're more than welcome to pause this video and try to go over it yourself and then check how you did. So let's go ahead and get started. It says how many grams of sodium hydroxide are needed to neutralize 20 milliliters of a 0.15 molar solution of sulfuric acid. So here, remember, we're going to start with anything other than molarity. So we're going to start with this 20 milliliters here. So we have 20 milliliters. And remember, this is my sulfuric acid. And we know, because it says 20 milliliters of, and then it says H2SO4. Remember, we cannot do anything in milliliters, so I need to get it to liters first. So 1 liter is the same thing as saying 1,000 milliliters. Now that I have it in liters, I need to somehow go from liters to moles. Remember, we do that with this molarity right here. This can be rewritten as 0.15 moles all over 1 liter. So if we're going to do this, we can say 1 liter and then 0.15 moles. Okay. Now that we've got it into moles of our first compound, we have to get to moles of our wanted compound, which is sodium hydroxide. Remember, to go from moles of one to moles of another, we need to use our mole ratio. So note that I've canceled milliliters, I've canceled liters, but now I need to cancel moles. So I'm going to put moles of H2SO4 on bottom, and you want to get to moles of sodium hydroxide. Mole over mole is mole ratio. So let's look at our problem. We have a 2 in front of sodium hydroxide and then a 1 in front of sulfuric acid. But it's not asking for moles of sodium hydroxide. I want grams. So remember, from moles to grams, we're going to use molar mass. So we can put moles of NaOH on bottom. And then if you calculate that molar mass, it's 39.9969 grams. Note that this is the molar mass of sodium hydroxide, NaOH, right there. Then we can go ahead and calculate across like we've done in previous problems. I want to round to 2 sig figs. You originally get 0.23998, but this 9 rounds that one up, and unfortunately, since that's a 9, it'll round this up to 0.240 grams of NaOH. Again, make sure that you're labeling because you are working with different compounds here. Now, this third example I've chosen to do because it's a little bit different. We're not starting with milliliters and we're not starting with liters. Notice here, the only thing that is not molarity is this 0.1 moles. So I'm going to write 0.1 moles of my lead PbNO3 nitrate. I don't have to go from grams to moles, and I don't have to go from milliliters or liters to moles because I'm already in it. So this is where a lot of people mess up because they try to use this molarity here in the beginning. Note, the mole goes to lead, but my molarity goes to HCl. So that's the key difference, noting who they're connected to. If I'm already in moles, I can go straight to my mole ratio. There's no reason. I'm already at my middleman. So I need to figure out my moles of my PB, so lead 2 nitrate, and then my moles of my hydrochloric acid. Remember, mole ratio comes from the balanced chemical equation, so 2 moles. And then here, this one is 1. So I've canceled out my moles. But I want to get to liters, and this is where this number is going to come into play. To go from moles of my given wanted compound to my liters, moles and liters, that connection is molarity here. So remember, this is 0.5 moles always over 1 liter. So the number 1 gets attached to liter here on the top. My 0.5 gets attached to my moles on my bottom, and that's what allows me to cancel out moles of HCl. And I'm left with liters. When you go ahead and solve this, your calculator will say 0.4, but because of rules, sig fig rules tells me that I need 3 sig figs, and I only have 1 right now, so 0.400 liters, and then my compound of HCl. If this was asking for milliliters, you could have done one more step and switched liters to milliliters, again by multiplying by 1,000 if needed. And let's do this very last problem. It's similar to the last one, but instead of starting with moles, we're given grams. If you want, again, you can pause this and see how you do. But otherwise let's get started. It says, what volume in liters of a 0.502 molar hydrochloric solution is needed to neutralize 4.24 grams of iron 3 hydroxide? Well, first, again, we want to start with anything other than molarity. So here we're going to start with this 4.24 grams. Notice it's attached to your iron 3 hydroxide. So first thing, we always want to try to get to moles if we're not there. And we're not. We have grams. So remember, to go from grams to moles, we need to use molar mass. So here, we did molar mass all last chapter. Our molar mass of our iron 3 hydroxide is actually going to be 106.8657 grams, and this is grams of your iron 3 hydroxide. Now, this is grams per 1 mole because that's what molar mass is of my iron 3 hydroxide. So now I've gotten it out of grams and I've gotten it to moles. I can go from moles of one compound to moles of a completely different compound using our mole ratio. So moles of our iron 3 hydroxide to moles of our hydrochloric acid. Notice mole over mole, we have to get this from our balanced chemical equation. So HCl has 3 and FeOH3 has 1. That allows me to cancel these moles, and I have moles of HCl. But I want liters of HCl. So the only way to get to liters of HCl is to use molarity. Remember, this is written as 0.502 moles over 1 liter. So if I want to cancel out moles, it has to go diagonal. So that 0.502 moles has to go on bottom, and then 1 liter up top, and these are both HCl. Now I've canceled out moles. I'm left with liters. That's what I want. So then I can go ahead and I can solve across. And if you're rounding to the correct number of sig figs, here this problem should have 3. You should get 0.237 liters of HCl or hydrochloric acid. Just like any other day, if you are struggling with these problems, need help make sure that you guys come up and ask, but also make sure that you've written down some of the stuff in this video. I go over important things, I write down important things, and so you need to make sure you have that information when you guys come up. So, otherwise that, I hope you guys have a great day. Bye.